We're going to determine if the series, the summation from 1 to infinity of 1 divided by the square root of n plus 1 plus square root of n plus 2 plus square root 5n plus 2 converges or diverges. And we're going to determine it using the limit comparison test. And let's recall what that is. Limit comparison test says that if we have two series, we call the summation a sub n, that's the first one, and the summation b sub n, that's the second one, with the restriction that an and bn are positive for all n if we take the limit as n goes to infinity of an over bn, and that limit, let's call it L, is positive and finite. Then the two series either converge or the two series diverge. So we can express it this way. Either the a sub n series and the b sub n series both converge, or the a sub n series and b sub n series both diverge. Now what cannot happen, the a sub n series converging and b sub n diverging, and vice versa. So let's return to the problem. We'll denote summation from 1 to infinity a sub n as our series, summation from 1 to infinity of 1 divided by square root of n plus 1 plus square root of n plus 2 plus the square root of 5n plus 2. Now what we have to do now is, based on a sub n, determine b sub n series, so that first of all it's simple, that is, we know if it converges or diverges, and second, that the limit of an over bn as n goes to infinity will be finite and will be positive. Now let's examine this term closer. We note that in the denominator we have square root of n plus 1 plus square root of n plus 2 plus square root of 5n plus 2. The highest power of n that we see in the denominator is almost like square root of n. So we have square root of n plus square root of n plus another square root of n. That's like 3 square root of n, and then some constants multiplying that. So the clue for selecting the series b sub n is as follows. The numerator here, the highest power of n in the numerator is 0. The highest power of n in the denominator is n to the 1/2, so we'll call it power 1/2, and the difference between them, denominator minus numerator highest power, is equal to 1/2. And that's the way we're going to select our b sub n series. We'll pick it as the simplest possible series, so that the difference in the highest power of n of denominator minus numerator is 1/2, and of course that series is summation n equals 1 to infinity of 1 divided by n to the 1/2 power, which is the same as the summation n equals 1 to infinity of 1 divided by the square root of n. And now let's go ahead and compute the limit as n goes to infinity of an over bn, and this is equal to limit n approaches infinity of 1 divided by square root of n plus 1 plus the square root of n plus 2 plus the square root of 5n plus 2 divided by 1 over square root of n. Let's use some algebra and evaluate this limit. This is limit as n approaches infinity. We can rewrite it as square root of n in the numerator divided by the square root of n plus 1 plus the square root of n plus 2 plus the square root of 5n plus 2. Let's divide both numerator and denominator by square root of n. When we do that, we have limit as n approaches infinity. In the numerator we'll get 1, and in the denominator we'll have square root of n plus 1 over square root of n plus the square root of n plus 2 over square root of n plus the square root of 5n plus 2 over the square root of n. Let's rewrite that. That's the same as limit n approaches infinity, 1 divided by, since we have both square roots in the denominator, that's the same as n over n, which is 1 square root of 1 plus 1 over n, plus square root of 1 plus 2 over n, plus square root of 5 plus 2 over n. And now let's take the limit as n goes to infinity. So 1 over n here, 2 over n here, and 2 over n here all go to 0. We are left with 1 plus square root of 5 in the denominator. That's 1 divided by 2 times, or 2 plus the square root of 5, which is our limit L. It is clearly positive. It is finite. So we can draw the conclusion now based on the limit comparison test. That is the series, the summation from 1 to infinity of 1 divided by the square root of n plus 1 plus square root of n plus 2 plus the square root of 5n plus 2. This series, and the series, the summation n equals 1 to infinity, 1 divided by square root of n, or n to the 1/2, both of these series converge or they both diverge. Well, we look at this series, we recognize this is a p series, and p is equal to 1/2. Therefore, this series diverges. And by limit comparison test, we can now conclude that this series also diverges, and we can say why by limit comparison test, which I'll abbreviate by LCT.